right, getting into mixtures. Most of the time, when we think of a mixture of something, we think of mixtures being liquid form. Well, mixtures can be gas, very easily represented, and you might even think of your atmosphere when you think of mixtures, because our atmosphere are made up of gases that are all mixed together to form Earth. So it's easy to understand mixtures when you're thinking about gases or liquids because it's something we experience every day. A lot of people don't realize that solids can actually also be mixtures as well. And some examples are alloys. Alloys are mixtures of metals, and we use those all the time, and you don't even realize. So there's two types of alloys that I do want to bring up. The first one is called a substitutional alloy. So these metals are in the solid form, and metals are going to form something called a crystal lattice. A crystal lattice is just its shape or pattern when it is in the solid state. So crystal lattices are going to have the metals very tightly compacted, and they're going to form a pattern. So let's say this was zinc. All right, here is our zinc crystal lattice. So they're a bunch of metal atoms, very close. They're not physically attached, but they're very close to one another. They're very condensed. So they just kind of vibrate around their bonds. So they're not really moving back and forth. They're just kind of shaking in their fixed position. So this is a solid, and this is what zinc or copper would look like. So if, let's say this was, let's use copper. So this is our copper crystal lattice. Well, what we can do is we can take out some of these copper atoms and we can put in another type of atom, metal atom, and it would form a mixture. So a substitutional alloy is going to be metal atoms of different metals that are going to be substituted into the original crystal lattice. So let's go back to our copper up here, and let's say I'm going to substitute some of these copper atoms for zinc. So I'm going to take this. This is now going to be zinc, 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 zinc. Okay? This right here would be a substitutional alloy. Think of things like brass or bronze. All right? That's how we make them. We take out, so brass is a substitutional alloy where we take copper and we're going to substitute it in with zinc. All right? Substitutional alloys are always going to change the color from the original metal. So, for example, if I tell you we're talking about copper, you automatically know in your head what color it should look like. Copper is going to be a very brownish red metal. All right, very commonly seen. Think copper wire, copper sheeting, copper cups, the color of copper penny. Okay, well, if I go in and I substitute some of those copper atoms with zinc, my color is going to change. It's no longer going to be that reddish brown color. It turns into almost a golden color, so it makes brass. All right, so your substitutional alloys, we're just substituting in a different metal into some of those atom spaces, and it's going to change the color of the original metal. Your next type of alloy that's very commonly used in industry and in sports is called an interstitial alloy. And an interstitial alloy is going to take a metal and we're going to fill in the spaces in between the compacted solid. All right, so we're going to take different metal atoms and we're going to place them into those spaces in the solid structure. So a very common one is steel. We do this to make steel. So what we do is we take iron. So we take the iron crystal lattice. And what we do is we take in carbon atoms because carbon is really small compared to the iron and it can fit in the spaces. And what we do is we take those carbon atoms and we fill in the little gaps in the crystal lattice. And that is what is called an interstitial alloy. And that's how we make steel. Just kind of a little example here, because a lot of people don't realize that solids can be mixtures too. And our best examples of solid mixtures are our alloys, and you do use them all the time.